in the activity, what was your angle of rotation for number 3? 45 degrees. That was a nice one to pick up, right? 2 over 2 up 2. We rotated 45 degrees. What distance did you walk out? 2 radical 2. So your in number 3, you have the coordinate 2 radical 2, 45 degrees, or pi over 4. Which one? We rotate pi over 4 and then walk out the distance of 2 radical 2. What did you use to help you get those numbers? Pythagorean theorem assisted you with the distance that you walked, the r, correct? What about the angle? The triangle relationships. Okay, good. How about in number 4? I made you do the coordinate -3, 4. What distance would you walk out? That r value, what was it? It was 5. Once again, the Pythagorean theorem helped you come up with that, right? That was a nice one, right? Now, Gabe, what about your angle for that? Talk to me about how you got that one. Your little triangle. Okay. Okay, essentially you used the inverse tangent with 3 and 4 to find the angle, but you knew -3, 4 was in the second quadrant, so you made your angle there. Okay? Does this math feel awfully familiar? Right? Okay. You just figured out what a polar coordinate was without me having to tell you. The distance that you walk out from the origin, that is your r. Okay? The distance that you rotate, we call that theta. All right? And just like xy is in alphabetical order, our theta is in alphabetical order as well. Okay? So we're going to come back to that bonus here in a moment. So here's the differences. Okay? Our rectangular coordinate system, that's the Cartesian coordinate. X represents horizontal distance, Y represents vertical distance. We count over and then up, over then down, over then up, whatever it is. However, for polar coordinates, we have the coordinate r theta. Theta is the angle that we have to rotate from the positive x-axis. And then r, we describe as the distance from the pole. We don't call this the origin anymore. We call it the pole. Okay? You'll notice on the back side of your activity, you have those funny looking dartboards is kind of what I would describe it as. Okay? That's a polar coordinate graph. All right? Instead of having the grid lines that are vertical and horizontal, we have rotational grid lines where we move out the distance of r and then we can rotate our angle. You notice that the ones that are on your piece of paper have nice 30, 45, and 60 degree angles. Okay? So those can help you as you plot the coordinates. Now, a couple of things I do want to point out. Let's go back to your, we had the coordinate 2 radical 2, so that's radical 8. 45 degrees. There's your coordinate from the beginning. Who would like to share another way to write that coordinate? You had 2 radical 2. A lot of you wrote 45 degrees, I saw. What's another way to write that coordinate?
Our group had -2 radical 2, 5 pi over 4.
That is exactly what I wanted to talk about. Thank you. What does it mean if we have a negative r?
You go backwards.
You go backwards. So if we were to rotate to 5 pi over 4 and then walk backwards to radical 2, we would be in the same place. Okay, it is possible to have a negative r value. It just means you're moving backwards before you rotate. Who had a different way besides what pod 2 had? I know you guys were talking about one. What was yours?
We just subtracted 360 degrees.
So you had negative 315 degrees. Okay? It is okay to have a negative angle. You can have a negative angle, you can have a positive angle, you can have a negative or positive r value. It's just telling you the direction of the movement that you're going to take. Alright? So before we get to lunch, let's talk about all of the trigonometric concepts that you use when you are out there in the hallway. If we have a coordinate and we know the x and we know the y, what did you use to find r and theta? So pod 1, what did you use to find r? Pythagorean theorem. So x squared plus y squared equals r squared. Write it down. That is a conversion that you need. If we know x and y, we can find r with the Pythagorean theorem. Now, I know some of you are thinking, I don't need to write this down, Mrs. Holman. I know the Pythagorean theorem. But eventually, we're going to have to convert equations, and you're going to want that as a visual reference on your paper for right now. Okay? All right. Pod 4, what did you use to find theta? Okay, we know that the tangent of theta is going to be y over x. That's really a lot of what we just got done doing in vectors and trigonometric complex numbers, right? Okay. All right, now I did not have you think of this, but I'd like you to take a moment and talk about it with your group. What if I gave you r and theta? How would you find x and y? I'll give you about 60 seconds. All right, I've heard a couple of ideas. Is anybody brave enough to share theirs?
I said like you could do the trig form where you have like the magnitude times cosine of the angle, and that gives you the x value, and then the magnitude times the sine of the angle gives you the y value.
Okay, if we think about knowing r and theta, we know the hypotenuse of this triangle and we know the angle. So if we're looking for x, the adjacent side, right, we know that the cosine ratio of theta better be x over r. Do you agree with that triangle relationship? So yes, r times the cosine of theta would equal x. And we can do the same thing. We know that the sine ratio of theta is opposite over adjacent. So our y value would be r times the sine of theta. These four conversions are going to be vital in this unit. Okay? Now, you know the trig behind why these work. So you don't have to set this up. You don't necessarily even have to draw the triangle every time. Okay? You know the math behind why these are legitimate, so we're going to be able to use those. Okay. I'm actually really excited that we chose to switch the order of chapter 10 because I feel like coming out of chapter 6, this is going to feel really familiar. Okay? Before we go to lunch, I want to plot a couple points. And so you have your graphs on the back of your paper that will help you. Okay? So I want to plot the coordinate 3, negative 3 pi over 4. Okay, so go ahead and write that down so you know what you're plotting. Now, this coordinate is written r comma theta, but I always like to rotate the theta and then walk out the r. Okay, that way I know I'm in the right place. So for this one, negative 3 pi over 4 would be here. Do you agree? And then if I wanted to move out the positive 3, I could do that by these concentric circles. So 1, 2, 3. That is the coordinate 3, negative 3 pi over 4. Okay. So those concentric circles are like your grid marks. Okay. Now, there are going to be multiple ways to represent this coordinate. With keeping positive or negative angles less than 2 pi, I guess angles between negative 2 pi and positive 2 pi, I want to come up with there's 3 other ways we could represent this coordinate. Okay? There's only 1 minute till lunch, and so I'm not going to give you as much time as I wanted you to think about it. But what if I kept with a positive 3? What is a different way to represent that angle? 5 pi over 4. And that's probably the easiest way to think about that coordinate is rotating to 5 pi over 4 and then walking out the 3. All right? What angle would we need to write if we had a negative 3 for our r value? If we rotate to pi over 4 and then walk backwards 3, then we would be at the same place. The positive. What would be another angle that we could use to describe that if we have negative 3 for our r value? Not quite. Not quite, but it was a good thought.
Negative 7 pi over 4.
Okay, we could rotate all the way in the negative direction, negative 7 pi over 4, and then walk backwards the 3. Okay, we will take a timeout for lunch, and we will pick back up when you get back. Here. Okay. So we've talked about what polar coordinates are, we've talked about the conversion formulas, and we've talked about how to plot them. Are there any questions on how to plot them? Okay. Let's talk about converting coordinates. We are going to convert coordinates, and then we are going to convert equations. So this is our first conversion. This is a rectangular coordinate, negative 1, 1, and we're going to convert it to polar form. You should notice that a lot of what we do will be, we'll have special numbers attached, okay? So this negative 1, 1, some of you already have the wheels turning on why that's special. Okay? So first of all, let's just keep in mind that negative 1, 1 is in the second quadrant. So first of all, you all figured out that in order to figure out the r value, how far away you walk from the pole, we use what? Say it. Pythagorean theorem. So r squared is negative 1 squared plus 1 squared. So yes, technically r is plus or minus radical 2. It's okay to have a negative r, but I'm going to ask that you go ahead and keep your r's as positive r's when you're doing these conversions, just for the simplicity of matching answers with other people and then along with me grading it, okay? Let's just go ahead and stick with the positive r value, okay? We shouldn't even need our calculators for this one. If we're going to find theta, okay, we talked about how the tangent of theta is y over x. So we have the tangent of theta is -1. That's a special tangent ratio. And we know that we are in the second quadrant. Jen, what's our angle? 135 degrees. I'm going to go ahead and write that as 3 pi over 4. When you can, I would like them in radians. Okay? Which is the same as 1. So that would be our coordinate. Okay. Please be careful, just like you had to do with vectors in trigonometric complex numbers, make sure that the coordinate matches your angle. Okay, so if you have a 4th quadrant coordinate, your angle better be in the 4th quadrant as long as your r is positive. Okay, just make sure you think about where that coordinate is graphed to make sure that your coordinate makes sense.
Do you not write the positive, negative in the...
No. So when we have coordinates, we could have a negative r or we could have a positive r. So I like you to just choose one. And when we're doing conversions, it's going to be easier if we just choose the positive one. Does that make sense?
Yeah.
If we chose the negative one, then we'd have to do something different with our angles.
Yeah.
Okay. All right. Now, this really wasn't bad. We had to think a little bit, but it wasn't too strenuous. Converting the other way is going to be even less work for us, in my opinion. Okay? If we have r and theta, getting back to x and y is simply applying those equations and thinking about our unit circle. Okay? So we have the coordinate radical 3 pi over 6. Okay? On our conversion page, we talked about how x was r cosine theta and y was r sine theta. So in this case, r is radical 3 and theta is pi over 6. The cosine of pi over 6, what is it, Connor?
Cosine of pi over 6 is yeah, okay. No, square root of 3 over 2.
Sure about that? Which one do you want? Thank you.
Yeah, square root of 3 over 2.
Okay, good choice. Radical 3 over 2. So then the x coordinate is going to be 3/2. For our y coordinate, we're going to take r sine theta, so radical 3 times the sine of pi over 6. So we have radical 3 times 1/2. So our y coordinate is radical 3 over 2. Just like in last chapter, if there's anything that involves a special angle, I need you to keep it exact. If I remember correctly, you will not get your calculator for the polar coordinate portion of our test, because you're not going to need it. It's all unit circle stuff. All right, let's talk about converting equations. Typically, you're going to see polar equations solved for r, much like we typically see rectangular equations solved for y. Now, that doesn't happen all the time. There are always exceptions to the rule, but I'm just going to throw it out there that that's what we're typically going to see. Okay? All right, here's our first equation, r equals 2. I will tell you that when we're converting polar to rectangular, I can't really give you a strict set of definitions or steps that I want you to follow. You basically need to be creative. Okay? So we need to think about anything we know that involves r, and how can we take r and get it into terms of x and y? Any thoughts?
One of our equations is like based on the Pythagorean theorem with x squared plus y squared equals r squared.
Okay. X squared plus y squared equals r squared. If we wanted to use that with r equals 2, what would we have to do to both sides? You understand what you're saying? We have to square both sides. Is it legal to square both sides of an equation? Okay. So we can square both sides and write r squared equals 4. Now we know that the substitution for r squared is x squared plus y squared. We now have an equation in rectangular form. What is this equation? A circle. Look how simple it is to write a circle with the origin as its center in polar form. R equals 2. Okay, the radius is 2 all the way around. We will get into more of graphing circles on Monday. Okay, so more to come there. Our next equation is this. Theta equals pi over 3. We somehow need to get this from theta to x's and y's. I'm going to give you a moment to just think. Look at your conversion, see what you have. What involves theta and x and y? Caroline? Okay, we know that the tangent of theta is y over x. So if we have tangent theta, we know we can make a replacement, right? Or substitution. So since we have theta equals pi over 3, we can write the tangent of theta equals the tangent of pi over 3. Okay, essentially we took the tangent of both sides. Is that mathematically legal? As long as we do something to one side and the other, we're okay, as long as they're the same thing, okay? Now we have the tangent of theta. On your conversion chart, the tangent of theta is the same as y over x. And what is the tangent of pi over 3? What? Yes. No, you were right the first time. Radical 3. So if we rearrange this might look better. Y equals radical 3x. What do we have? We have a line with slope radical 3. That sounds awful to graph a slope of radical 3. However, think about this. on our graph, we have a line where the angle is always pi over 3. That's what we have. We don't have to graph slope of pi over radical 3. We can just graph a line that has an angle of pi over 3. Is that cool? See the excitement in your eyes? Okay, now, when we're converting the other way with our equations, we do have a more systematic way of doing it. Okay, when we have polar equations, we have to be creative in order to make the substitutions. Okay? However, when we have a rectangular equation, we know what x and y are, right? And so at the very least, you can plug in x equals r cosine theta and y equals r sine theta. Okay. I do want you to solve for r when you are converting to a polar equation. If there's not an r, then you can solve for theta like we saw in that previous example. Okay. But I do want you to solve for r, if there is one. Here's our first example. I would like you to turn to your neighbor and tell them what substitution you think we can make. All right, Pod 3, suggestion? Okay, x squared plus y squared, we can replace with r squared, which means r squared is 16. Remember, I do want you to solve for r, which means r equals 4. Okay, this looks familiar, right? Before we had r equals 2 and we got back to something that looks like this. Okay, now we took a circle and converted it into polar form. All right. 2 examples. This is the first. And one more, and then we're done. All right. Y equals x. What is it? It is a line. Okay. Now, you could go about this a couple different ways. But if you are really stuck on what to do, at the very least, you know that y is r sine theta, and you know that x is r cosine theta. Okay. Now from here, all right, we got to figure out what to do. What do you think? Cosine over sine is tangent. So here I have r equals r cosine of theta. Oh, you said, right? R sine theta. If we divide over that cosine theta, that's going to become tangent, right? And what happens with the r's? If we divide over the r, it's going to go to 1. So right now we have the tangent of theta equals 1. It's okay that the r's go away, but I told you that if there is not an r, I want you to solve for theta. So what is theta if the tangent of theta equals 1? Theta equals pi over 4. A line that goes through 0, 0, we can express as theta equals some angle. So theta equals pi over 4 is just the line y equals x. Okay. All right, ready to get crazy?
Sure.
This is a line that does not go through the origin or the pole, whichever coordinate system you're looking at. Okay. What did I tell you to do when you saw an X, if you didn't know what else to do? And if you saw a Y and you weren't sure what else to do, plug in r sine theta. From here, all we have to do is solve for r. Okay? So we can add 2 over to the other side because it doesn't have an r. And if we are solving for r, what could we do to the right side? Not the right side. The left side. Okay. We can factor out an r. I totally had you all panicking, right? What do you want me to say, Mrs. Fuller? Okay, both terms on the left side have an r, which means we can factor it out. So to solve for r, we would have 2 divided by 3 cosine theta plus 5 sine theta. And that is the equation of our line. Now, it's not pretty, is it? Okay? You're going to find that there are equations that are a lot nicer in polar form, and there are equations that are a lot nicer in rectangular form. And we'll get to play around with those throughout the next few days. Okay? What I would like you to do, because we're not going to start our homework in the next 4 minutes, I would like you to partner up at your table. Maybe Nicole, you can go partner up with Brian back there, and everyone has a partner. Okay? I would like you to plot a point on the back of your worksheet. Okay? So you probably plotted on this one. Plot a point over here and have your partner name that point in 4 different ways. There's 4 different ways to write it. So plot a point and then exchange papers and see if you can name each other's points. All right? 1, 2, 3, go.